Yes, hello, hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. And we are looking at this question. It says, platinum catalyst was added to the equilibrium below. And this is the equilibrium. We don't have to forget that this is also a vapor. Okay, it says instead the effect this will have on the rate of reaction. What are you adding? You're adding a catalyst. And the catalyst is one of the 6 factors affecting the rate of reaction. So what is going to be the answer? Increase. Okay, let's look at the next question. Yeah, next question says the Kc value. So what is the effect of catalyst on the Kc value? Okay, the answer is no effect. We have to remember that the only factor affecting Kc value is temperature. Anything outside temperature has no effect on the Kc value. Next question. So there comes the next question. Remember, we are adding a catalyst. And what is the effect of adding a catalyst on the yield of nitric oxide? The answer is no effect. Why? A catalyst favors both forward and reverse reactions to the same extent, so it does not shift the position of equilibrium. Okay, so this is the next question. What is it? The position of equilibrium. What is the effect of adding a catalyst on the position of equilibrium? The answer is no effect. Like I told you before, a catalyst favors both forward and reverse reaction to the same extent. So under that circumstance, it doesn't shift the position. Thank you. So then comes this question. It says, the pressure on the system above is decreased by increasing the volume. It says, use the Le Chatelier principle to explain the effect this will have on the yield. Now, to explain this question, you require to have the equilibrium. Let us see the equilibrium. So having this equilibrium, and we are assessing effect of pressure. First of all, we have to ensure that all of that these ones are gaseous. So what do we have here? You do the count. These are there. When you count, how many moles do you have here? We have 9. And this side, how many moles do you have here? 4 plus 6, you have 10. And what are we doing? We are decreasing pressure. You have to remember that decrease in pressure favors the change from lower number of moles to high number of moles. So the change will be in that direction. What does that mean? It means that the reactants will react to form the products. So reactants will decrease and products will increase. And the products reflects the yield. So the answer is going to be increase. Okay, that's the answer. But they said use Lechetaria's principle. So Lechetarian says that the system does not want to be disturbed. So decrease in pressure favors the shift in the direction which increase pressure, and that direction is forward. Thank you. So that is that according to Lechetarian, decrease in pressure favors the direction which increase pressure, and that direction is forward. Okay, so we go to the next question. Okay, then comes this question. It says that when the temperature of the equilibrium below is increased, the equilibrium constant is also increased. So this is the equilibrium we are talking about. Ammonia reacting with oxygen to give you nitric oxide and water. Then the question says, sketch potential energy diagram for the reaction, indicating reactants, product, activated complex, and activation energy. Something is missing here, and no values are needed. No values are needed. Okay, there we are. How do you approach this question? Okay, the approach is we need to establish whether the reaction is endothermic or exothermic. Okay, you have to remember that for endothermic reaction, when temperature increases, Kc also increases. And when temperature decreases, Kc also decreases. That's for endothermic. For exothermic, it's the other way around. When temperature increases, Kc value decreases. And when temperature decreases, Kc value increases. So from that statement, what is this? Okay, let us analyze it. What did we say? Temperature increased. Kc increased. That is depictive of endothermic. So the reaction is endothermic in nature. So when they say sketch potential energy diagram, they want you to sketch potential energy diagram for endothermic reaction. Let us sketch it. So if these are our axes, what do we say? On this one, you have potential energy. And on this one, we have progress of reaction. Okay. After that, what do? We do our sketch. It is supposed to be for endothermic. Okay. So we have that representing reactant. We have this. So it goes, curves there, comes and stop there. So here we have the activation energy. Instead of the reactant, we can put the actual molecules like 4 ammonia and 5 oxygen. Here we can put nitric oxide and water. Okay, yeah, that's the thing. Activated complex is this one. Okay, anything left out? Sketch potential energy diagram indicating reactants, product, activated complex, and the activation energy. So next time, if they want you to indicate enthalpy change, it is here. So generally, that is the sketch for potential energy diagram in kilojoules versus progress of reaction. Okay, that's for the endothermic. So with that, we would like to cut this video here. Please follow us to the next video. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard. See you next time. Bye.